In today's video, I'll be explaining to you another very interesting method known as JOMU's method that can be used to solve the simultaneous equations in 2 variables or 3 variables. This is the second method that I've developed to solve simultaneous equations. Now, before we look into this method, I want to inform you again that on this YouTube channel, I don't teach mathematics, but I teach my own methods on how they can be used to solve mathematics. All methods that I've explained on my YouTube channel and I'm yet to explain, some of them, should I say most of them, have been actually sent for publications in the mathematics journal. I've also submitted some to the local Curriculum Development Center for consideration to be included in our school curriculum for mathematics. Sit back and relax and watch this very interesting method, how it can be used to solve the simultaneous equation in 2 variables. Solution. I have x minus 3y equals 8, 3x plus y equals 4. I'll multiply the first equation by 3, the second equation by 1. What I'm trying to do is to make the coefficient of x become exactly same. If I want, I can make the coefficients of y become exactly the same, as if I am doing elimination method, when actually not. And just an emphasis, if I want to make the coefficients of y become same, I don't need to multiply the second equation by positive 3, which is here. Should I say the 3 that I have here, I don't need to multiply it by the second equation. I need to multiply it by negative 3. So that even the signs, that's how this method works. The signs must be the same, not just the coefficients that should be equal, but also the signs that they carry should be exactly the same. So let us, this time around, make the coefficients of x become equal. So I'll multiply the first one by 3, I'll multiply the second by 1. So 3 times x gives me 3x, 3 times negative 3, that is negative 9y equals 3 times 8 gives me 24. Then 1 times 3 gives me 3x, and 1 times positive y gives me positive y. 1 times 4 gives me positive 4. Now that is actually done, I am going to take one of these coefficients. In this case, I have my 3x equal to, I'll multiply negative 9y by 4 minus, I'll multiply y times z positive 24. As if it is actually determinant I am calculating. So that becomes 3x equals negative 9 to multiply with this, so negative 9y multiplied with positive 4 minus positive y with 24. Then I divide negative 9y minus y, that is negative 9y minus y. Our 3x equals negative 9 times that gives me negative 36y minus negative y times 24 gives me negative 24y. Negative 9y minus y gives me negative 10y. So our 3x equals negative 36 minus 24y gives us negative 60y. I divide by negative 10y. So you check at that particular point, negative 60 and negative 10y can actually be divided because 60 is exactly divisible by 10. At that point also, y needs to cancel. So our y and y cancels. Then the next thing is to divide negative 60 by negative 10. So our 3x equals negative 60 by negative 10. That gives me positive 6. Then I can divide by 3 by 3. Then x will be equal to positive 2. Now, if x is positive 2, I can easily find the value of y by using substitution method. If I don't want to use substitution method, I can go back and again solve for y using the same steps that I've used to solve for the value of x. Now, not to waste time, we can just substitute positive 2 into one of the equations that we have, the first two equations. Now, so if x is equal to positive 2, now using the first equation, our positive 2 minus 3y, that gives me positive 8. Then I can correct the like terms here. Negative 3y is equal to positive 8. Then minus 2, that gives me negative 3y equals positive 6. From here, we can divide throughout. That would be negative 3, and my y becomes negative 2. Therefore, our final solutions will be equal to the value of x is positive 2, while the value of y is negative 2. That marks the end of this video. Thank you very much.